Hi everybody, this is submission 57, Accounting for a Technological Agency in Smart Energy Systems Governance towards a Conceptual Basis. My name is Paula Hansen and I will be co-presenting with my colleague Ted Mose. We are both based at the University of Oxford and working on the Oxford Martin programme on integrating renewable energy. I'm going to start by giving you just a very brief introduction to what we're going to be talking about. So first of all, energy systems, as you're probably all aware, are undergoing transitions, and the most important aspect of that is that we're transitioning to a low carbon, more climate friendly, sustainable energy system. And then there's a second component driven by digitalization, where energy systems are becoming increasingly smart. Conceptually, as a conceptual base for our work, we understand energy systems as socio-technical systems, and that means, very broadly speaking, that there are social elements and there are technical ones. And then they interact to create the system overall. So the whole is greater than the sum of its parts. And so what we're doing is combining our backgrounds in energy law and energy resource governance to frame and conceptualize the problem of governing these emerging systems. We're going to outline two trends. The first one being increasingly bottom-up decision-making, and the second one being technological agency. And then we're going to talk about the implications of that in terms of law and governance. The first trend that we're seeing in emerging energy systems is that decision-making is increasingly bottom-up, and that's often kind of encapsulated by this shift from passive to active consumers. You've probably all come across this term, prosumers, which has become very popular, and it's kind of it's used to describe the fact that people can now not just consume energy, but they can also at the same time produce it themselves, for example, by installing solar PV on their rooftop. So there's this view that there's more involvement in decision making of citizens or individuals, however you want to frame it, especially with regards to ownership of decentralized energy generation and storage assets. And that means, in one way that means that there is more control with individual consumers in terms of the general structure of decision making. And that's also reflected in this shift from centralized to decentralized. But at the same time, we argue that the system is also becoming increasingly complex, and that means that decision-making power is not necessarily increased in all areas at all times.
More actor involvement in energy systems does not necessarily mean that those actors are empowered to make decisions or are included in deciding what happens in those energy systems. This therefore means that an increase in the number of actors and an increase in the complexity of energy systems does not necessarily democratize energy governance. Now, the practical involvement in energy systems, unfortunately, does not necessarily match the development of energy law, which is my area of expertise. States and major players in especially international energy law are the ones who are seen as the key actors and stakeholders, and they have what in law we call locus to participate in, say, international agreements and international forums. Other parties that participate in energy systems, including individuals, especially at international level, and if we come to national level all the way to the other tiers of law up to local level, are seen as subjects of the law. Now, this has certain implications because on the one hand, we're seeing that there's greater involvement of not just individual actors, but as we'll see further down, that there's going to be greater involvement of inanimate actors like technology, communications, and so on. And so this takes us to the next point, which is not all actors are equal. Even beyond the top, where we know the states and major corporations are deemed to be the largest players, the actors, emerging actors, are not all equal, and smart technology appears to have a disproportionately larger influence now than it did in the past. And therefore, technology can lead to further alienation of vulnerable members, of vulnerable participants in energy systems. And in particular, I'm thinking of the elderly, I'm thinking of the poor, and I'm thinking of those who have not had a certain level of education or technological nous to operate certain emerging smart energy systems.
The second trend we're observing is linked to the increasing focus on the role of digital and smart technologies in energy system management. And an example of this increasing focus is the UK government's strategy and action plan that was released in July, called Digitalising Our Energy System for Net Zero, where they highlight how important digitalization is for rapid decarbonisation and for us to be able to achieve rapid decarbonisation. Some of the barriers to achieving that they point out is a lack of shared digital infrastructure and a lack of common practices and standards. What we argue is that this trend, this increasing focus on smart technologies actually means that not only, building on the first trend we outlined, not only are decisions increasingly local and bottom-up, but also they're made not just by humans, but also by technologies. And so really integrating smart technology into energy systems is not just a technical issue, it's a social issue as well, and it's a political issue.
And on this slide, there are 4 points that I'm going to make that are based on certain considerations. When we talk about, say, the GDPR or the General Data Protection Regulation, it poses serious complexities because there are about 4 things that need to be balanced there. The first one is public good. When you think of energy systems, for example, and there is a limited supply of electricity, in certain countries we have what we call load shedding or rationing of power to ensure that the most critical industries or sectors receive power, or that there is greater distribution of power around the population. There are also questions, even in this country, of electricity system balancing. And so if automated decisions are made for public good, it becomes very difficult to argue otherwise. But at the same time, public good needs to be balanced by questions of privacy and individuals needing to have their privacy respected. We also have consumer protection questions there, where the quality and pricing of energy or electricity specifically needs to meet a certain standard. And then we have, of course, data protection. And when we speak about data protection, we go to the first question there, that technology poses, standalone ethical questions, things like data mining. If you have artificial intelligence, just running and just constantly learning about your consumer patterns and then using that to make decisions on your behalf, is your agency being taken away? And then, of course, we have commercializing individual data by third parties, and to what extent individuals or communities or the society in general has control over that. And then when we talk about smart systems and new innovations that are not fully understood and are poorly regulated, this is a fact, because smart systems are new and the law needs to evolve to meet them. And I will speak more specifically on this in further slides. So technology itself, or infusing technology, especially for renewable energy systems, creates new problems. And for example, we talk about data centers. I've spoken about artificial intelligence, machine learning. There needs to be servers that these systems need to be powered, and they might increase energy demand for their powering, heating, and cooling. And so the other question, of course, is some of these ethical questions will be discovered as we go along. And therefore, what does the law need to do, or what are some of the questions that we need to consider to see how there will be a match between governance, law, and the energy system?
So to summarize what we've outlined on the previous slides, what we're saying is that as a result of digitalization, technology in the energy system has agency. And by agency, we mean decision-making power and or the ability to learn and adapt behavior. And humans, of course, have varying degrees of agency, and this depends, for example, on the sources of electricity and on socioeconomic factors. So somebody who has who owns their own roof and has the financial means to install, say, a solar PV system on their roof has greater agency than somebody who doesn't own a roof and doesn't have the money. And then technological agency can be expressed, for example, in the form of algorithms, and is visible in things like automation, machine learning. And these capabilities of digital technologies are often portrayed as something very positive, as a solution to our problems, and they are also often portrayed as being better at doing certain things than humans are. As being fairer or less biased. What we're arguing is that we need to remember that in the end it always comes down to humans who program these algorithms. So on one hand, this technological agency means that there is less control for humans in certain aspects. So, for example, we can schedule appliances to switch on at certain times of day. That will then optimize our energy use, and that means that we don't have to learn what times are best, and we don't have to adapt our practices and routines. And that's very helpful. But on the other hand, it also raises questions of a number of questions, and an example is who monitors the monitor, and what we mean by that is who monitors the organizations or the humans who program algorithms and control, essentially like tell the technology what to do, right? So the implication is that there's questions, for example, of accountability. What we're saying is that this agency of technologies in the energy system is currently insufficiently accounted for. And if we don't account for both, so for human agency and technological agency adequately, then we can't govern effectively. And this is also, I guess, in parallel to the idea of joint optimization in socio-technical systems discourse. So it's the idea, because you have a social subsystem and a technical subsystem that create, by interacting, create the whole, which is greater than each individual subsystem. You have to jointly optimize them. So we need to account for both in governance. Or another way of looking at it would be to say that there is a disconnect between the top-down rule-making we're currently seeing in energy systems and the bottom-up decision-making that we're observing. And what we're suggesting is that there already is a body of literature that may very usefully serve as a basis to think about this more and to conceptualize it. And this is the literature on common resource governance. Elinor Ostrom is probably the most famous scholar in this area. She won Nobel Prize for Economics in 2009 for her work on governance. And what her work is most famous for is showing that humans can sustainably manage, govern and sustain scarce resources. Anyway, so at the heart of this body of literature is the idea of rules, and rules that structure human interactions. So Ostrom and her colleagues refer to these rules as institutions, or they're also known as rules of the game. And governance is about understanding these rules and developing them and amending them when needed. And so in terms of socio-technical systems, we understand it as the coordination of interactions and outcomes in socio-technical systems. And what we're proposing is that what's extremely useful about this body of work is this rule heuristic, because that's how algorithms work as well. So it's a common language that we might use to describe, analyze, talk about, discuss how to govern systems in which there are human agents as well as technical agents. The inclusion of technological agents being an extension that we're proposing. And the second useful bit of this body of literature is that they are assuming, or they talk about nested hierarchies, and especially the idea of polycentric systems of governance. And this is the idea that there are many centers of decision-making that operate under a common overarching set of rules. and this has been likened to the emerging structure of energy systems. The argument basically being that they are not just decentralized, but rather polycentric. Right. So what we're saying is there is a lot of potential in this existing work by adapting it to treat technology as an actor. And then in addition to that, we need to introduce a greater nuance in socio-technical systems discourse. And what I mean by that is that because of what we've outlined in this presentation, we can't just talk about socio-technical systems and leave it at that, because it's more complicated than that, because it's not just technologies on one hand and social things on the other. There are different types of technologies, and just physical infrastructure, for example, isn't the same as a piece of software that has decision-making power. So we need to be aware of these differences and treat them accordingly.
Law is a governance tool, and therefore, as a governance tool, part of the problem that we identify in this presentation is that law is not adequately regulating all actors. Law is not regulating all actors, and especially is not regulating inanimate actors, such as technology. And the smarter technological systems get, and the more control and agency they have, the law needs to also evolve to match that sort of function, or at the very bare minimum, recognize that. So technological development is, it appears, is clearly outpacing the development of the law, which tends to be slightly slower and easily much more granular, whether you're looking at this from an international level, or you're looking at this from a parliamentary level at the national level, and or you're looking at it from a local perspective. So for technology to be properly governed, it is essential from a legal perspective for technology to be recognized as an actor, or at least for the function that the technology does to be within the remit of what law, policy, regulation are dealing with. And so an actor in energy law, and this is an argument that I make, is that an actor in energy law need not be an entity or a party or a person that is formally recognized in law. We say sui juris, does not need to be a formally recognized legal person. What is important is to go beyond formalism and look at functionalism. And so smart, especially smart systems, have agency, they have influence, and therefore they need to be properly taken into account when regulating or designing or maintaining the resources that we have in energy systems. And the question therefore is, technology should gain recognition and legal personality for regulation. So this is not entirely new. Companies are inanimate creations of law. They are not human, they're not living creatures, but they are considered persons. We argue that technology, especially smart and automated technologies that have an agency in energy systems, ought to gain legal personality for better regulation. So how can we achieve this? We can achieve this through legislation, we can achieve this through regulation, we can achieve this through policy change. But I think from an academic perspective, it is also important to start conceptualizing these things, hence the title of our presentation today. We need to start conceptualizing and mainstreaming this sort of thought to have influence in those sectors. So what is the justification? Every legal field ought to be subject to its own specific jurisdictional rules to be able to best manage its functionality. Thank you. I'd like to recap some of the main points that we've handled today. The first is that energy systems have functionally evolved, but the governance architecture has not. And specifically to law, as I was talking about it in the previous slide, the recognition of technology as an actor ought to be based on its agency in energy systems, and not just necessarily because things like companies also have been similarly recognized as actors. And so how do we do this? The proposal here is that we either broaden the recognition criteria of stakeholders in energy law, policy, and regulation to include smart energy systems, especially automated ones, or law, policy, and regulation should shift their regulatory focus from, from formality to function in energy systems, such that it is not necessarily that because it is written in the law that regulation and governance should take a certain path, that then that's how the law should develop, but rather the law should develop to meet the functioning of energy systems, which would then make the law more relevant to doing what it needs to do. And so we need iterative legislation, we need iterative policy and evolving governance mechanisms to match the dynamism that we see in energy systems and the technologies that are emerging and innovations that are emerging. We can think of smart meters. It's not just about regulating the physical hardware. There's also the software bit that is most important. And I can give the example of a thermostat. A thermostat was a physical thing that when water got to a certain temperature would stop your boiler from working. This was the hardware. But the software now, when we think of smart meters, when we think of artificially intelligent systems, there may not be a physical switch that can be regulated. However, the question is not the thing itself, but the function of what it does, that it plays a certain role in systems, and therefore that is the role that needs to be governed. And so we do assert and propose to you, and I'm happy to take questions shortly hereafter, is that we need to recognize technological agency in analysis and discussions of socio-technical systems, especially energy systems. And two, we draw and learn from the common resource governance literature to make this, and from emerging international energy law literature to reach these conclusions. We thank you very much for your time and look forward to engaging with you in the Q&A section. Thank you very much.